Welcome again to another interesting video with another interesting guest as well, Mr. Matias Scheinin from the Turku University of Applied Sciences. He is a senior advisor and specialist in water pollution and also working in a research group. Welcome, Matias. Please tell us more about your work.
Yeah, thank you very much for the invitation. I work at the Turku University of Applied Sciences in a research group called Water and Environmental Protection. And as we are a University of Applied Sciences, we base all our work in basic foundational research. But what's especially important for us is to take the new results that we get from our research into practical use, or at least attempt to do so. So we also try to focus on the concrete societal applications of the research that we do.
That's really interesting. And you are like a walking library of water pollution expertise. We are interested to hear so many points how you would help us to actually take care of the shorelines and water pollution better. What do you think about the global situation with this very like trendy but quite concerning topic of the dead zones near the shorelines across the world? What do you think about those, and where do you think are the points that need to be concerned about, especially?
Yeah, that's a really important question. And I think that to understand dead zones, I think we have to look at how the coastal ecosystem deals with an overdose of organic matter, a process called eutrophication. And the ecosystem is essentially hit from two different directions. So, first, there are inputs from outside of the system. So, material entering the water from our activities on land and at the coast, such as forestry, agriculture, wastewater, and aquaculture. These sources deliver what I would call a double blow by providing both nutrients, which act as fuel, and organic matter, which acts as the physical burden. So in the water, the nutrients trigger massive algal blooms, creating even more organic matter. And when all this material eventually sinks to the bottom and decomposes, it consumes the oxygen. And this it is what creates the dead zone. So once oxygen is lost, a vicious cycle of recirculation begins. So the seabed itself begins to release old nutrients and carbon that were safely buried in the mud back into the water, fueling actually more growth from the inside. So this biological cycle is often worsened by physical disturbances, activities like dredging or heavy boat traffic, especially in shallow waters, because they can mechanically stir up the buried organic matter, kind of like reintroducing it into the water column to consume even more oxygen. So we're actually talking about a vicious cycle. I want to emphasize this expression. And the reason this is so difficult to manage is that water is fundamentally different from land. I know this sounds kind of lame, but on land, if you manage a field or a forest, the soil and trees, they stay put. But water, it's dynamic and fluid. It carries these inputs from outside and inside the system far from their source and keeps the recirculated material from the bottom in constant motion. So, because water moves this way, we can only solve the problem if we act according to the dynamic nature of water. So, we have to follow the flow to pinpoint exactly where the causes are and where the consequences appear. So, for each of us, this means being mindful of our own nutrient and carbon footprint, reducing the pressure we put on the system so that the water can begin to clear itself. And the positive news is that we are finally using tools that match the complex and dynamic nature of the coastal sea. So we're moving away from static guesses and toward high resolution mapping that captures these dynamic movements in real time, even. And by seeing exactly how the water flows and where the material accumulates, we can target our actions with high enough precision to break the cycle and restore the balance. So that's how I would put it. I would like to say in short, but I think I wasn't that short. Sorry for the long answer.
Really interesting, and I guess that is a topic that we can't really tell about it very shortly. It has to have enough time to say. Nowadays, we have a lot of 1 minute videos in Instagram, and information is really quickly shared. And there's a lot of disinformation about water and pollution and oceans and everything. Yesterday, just to go a bit aside the topic, but just to mention one example, I saw one video that was AI that was made from the deep oceans, the dark seas, and the very deep, because now we're learning a lot and using AI to learn that, the new knowledge, the new species. But this was AI, that was a fake species, and that was mixed with the science information in the Instagram flow.
Right.
So I'd rather hear a long story of facts and learn than have that 1 minute fake AI disinformation video. So it's really important, this information that you share us. And if I think about the dead zones, I just feel so concerned. So it's good to get these instructions, what we can do about that. And if you like tell the every man what they can do every day when they go to the grocery store or when they buy something and when they consume, what are the first steps that they can do? They say, okay, carbon footprint, pollution, but what is like the first little thing that they can start with?
Yeah, I think the main thing is to really think about how the groceries and other stuff you're purchasing, how they are actually being produced. And you don't necessarily get all the required information from the package. I mean, they might have some kind of like a follow a certain standard for sustainable production. But I think the story is, I wouldn't like to make it more complicated, but there are so many things that are still not yet taken into account. For instance, when you are determining the carbon footprint of a product, I mean, it's in the end, it's actually a subjective choice, like which, so to say, variables, which pathways and phases of producing that product you actually take into account when you are calculating the footprint. And I think this applies especially to coastal waters. And of course, I mean, I don't want to be talking about, I mean, I'm using carbon footprint as an example because I think that's familiar, something that's familiar to many people. But I mean, you could equally well be talking about a nutrient footprint. This is something that you might not see on the labels as often as the carbon footprint, some sort of a notion about that. But yeah, and of course, I mean, it's a hard endeavor to try to find out how everything that you consume is being produced. But I think also using common sense and having the willingness to really think about what you are consuming is a key thing. And of course, I mean, all of us are consumers, but then part of us are landowners and so on. And of course, especially like if you happen to own or even use land, I think you should really consider those practices and how they are influencing the waters, because water, regardless if we're talking about the ocean or lakes or rivers, that's where everything eventually will end up. So I think those choices that you make on dry land, they are crucially important for how our oceans are doing, and the coastal zone in particular.
We're going to go in a while to the amount of light in the waters, but before that, I would like to ask you more about carbon and the way that carbon in nature also is a part of nature and belongs there and has a role, but then when it's pollution, it's a problem. What is the difference between the carbon that is natural and balanced in nature and the one that is a problem?
Yeah, that's a really good question, and I suppose it might cause a bit of confusion because, I mean, especially nowadays, we often talk about carbon or organic matter, which are various substances that incorporate the carbon. So the carbon it's exactly the same thing. It's really the amount and the form, the chemical and physical form of that carbon that can turn it into a nuisance or something that we can also call pollution. So basically, I mean, we're talking about the backbone of life, but if you have too much of it in the wrong, so to say, or depending on the context, in the wrong chemical or physical form, then it becomes pollution.
As an ocean advocate and I guess oceans and water influencer of one of many, I am interested in learning a lot of new things. And even though I'm like 3 years until 60, I believe that if you want to protect nature and your time, you need to be aware and learn. So, to the audience, Matias is also my teacher. I was joining his online educations of water pollution and the water cycles, and very interesting information. And there we went through how much light there must be in the shorelines and waters for the ecosystem to be in balance. And that was really interesting to know that if the amount of sunlight is not sufficient, then the balance of ecosystem will have a completely different form or disbalance under it. Can you tell us more about that?
Yeah, sure. Thanks for another good question. So I'd say that to understand the coast, we have to look at it as if it, well, actually it is a solar powered system, I would say. So the very top layer of water, the first few decimeters, is the critical gateway through which all life-sustaining energy must pass. So when the light is sufficient, the shallow coastal zones transform into well-functioning underwater landscapes. So, for instance, in sandy areas, plants like seagrasses form meadows that act as natural anchors, binding the seabed using their roots or with their roots. And in rocky areas, algae like bladderwrack create complex habitats. So these underwater forests, as we call them, are vital because they stabilize the environment. They produce oxygen, and most importantly, they keep the water clear by preventing the seabed from being stirred up. Um, but we're I would say increasingly seeing a process called coastal darkening, at least around where I live, and in many other places around the globe. So, um, so, um, so basically, sunlight fails to reach these habitats. That's what coastal darkening is about. So this is a direct physical manifestation of the eutrophication I was just talking about, and it happens because the water becomes sort of like a dense soup of particles, a mixture of the organic matter washing off the land and the excess algae growth. So these particles absorb and scatter the light before it can reach the bottom, and this actually it actually triggers a second vicious cycle. So when the light is blocked, the stabilizing vegetation on the bottom dies. So without roots or structures to hold the seabed in place, the bottom becomes loose. So every storm or passing ship stirs up this fine sediment and organic debris. So this so-called resuspension pushes even more particles into the water column, uh, which makes the water even darker and richer in loose organic matter. So the ecosystem essentially gets stuck in a permanent shadow. But fortunately, the situation is actually much lighter because the so called solar engine, as I sometimes tend to call the coastal waters or the coastal ecosystem, is actually remarkably efficient at restarting. So once we reduce the load of organic matter and nutrients from outside the system, the particles in the water, they will begin to settle and the water clears. And as soon as the light returns to the bottom, we have seen that vital vegetation can recover actually surprisingly fast. And again, locking the sediment back down and permanently or more or less permanently improving the water clarity. So we can
It's
really do something about it as well.
It's really interesting. And to understand how important light is for life, it's like not only the light we see, not only the sunlight, daylight, but into the waters, especially coastal areas, because we know that after a certain amount of depth, light will vanish. So it's not going to go all the way to the deep ocean, of course. But the coastal lines, especially when it's more shallow, they need that light, and it's part of the ecosystem. Really interesting. And I realize to the audience, Matias is a very popular teacher, so he probably gets a lot of messages while we're recording. So yeah, I noticed a while ago there was a lot of messages coming in, and I've been joining your lectures, so I know you get like 100 messages a day. So that's a wonderful thing, and it tells about a super expert because he's also heard in the internet. So nowadays, teachers and experts are very much in the social media, which is a great tool for us as well to share Matthias's information now on a global scale in this recording today. So I'm really grateful you joined us today, and I would love to hear like hours and hours of your talk. But we would go into a couple of questions today because, of course, the time that people have to give us. So let's go into certain important points today. And of course, increasing water pollution, that is a fear. And will it decrease? Will it increase? What will happen in the next 5 to 12 to 20 years with water pollution in the shorelines? Do you believe it's going to get better than what it is today?
Yeah, that's a really big question, and yeah, I'm really positive about this. So maybe I could perhaps, if I may, take a couple of steps back, kind of like to give some perspective, like historical perspective for the future scenarios. So actually, the trend that we see is I would like to call it a complex shift. So in many regions, we have actually achieved major success by managing these so-called point sources, the direct pipes from cities and factories. And this was and is indeed a critical first step. But the success has also revealed a deeper challenge, which is diffuse loading. So, because land use is intensifying and the climate is becoming more volatile, nutrients and organic matter are being flushed from the entire landscape into our seas. And historically, we haven't been aware of the exact sources because this sort of pollution leaks from the whole map, so to say, not from a single pipe. And then in the coastal context, a major problem, as I see it today, is that our detailed understanding has actually often been an illusion, or that's what I would like to call it, because for decades we've taken spatially or temporally coarse, occasional, discrete water samples in bottles and relied on thin, perhaps a bit non-representative observations like satellites that occasionally see a handful of variables on the water surface and fed this information into complex models. And these models give an ostensibly detailed picture. They look detailed, but they might not give you information that actually is very accurate, although it looks like it. So they can be misleading because they lack the real representative data that we need to capture the actual dynamics of the water. So I would say that we are now on the verge of taking the next big leap forward by moving from or moving toward high resolution continuous mapping So instead of relying on a model's best guess, we're currently collecting the high quality representative observational data that the sea actually requires. So this new intelligence, this is not only data, I would like to call it intelligence. It allows us to pinpoint exactly where the material enters the water, and for the first time, also to see the concrete results of our actions or the real costs of inaction. So not taking the required actions. And I strongly believe that this precision can change everything. So we are no longer just monitoring a decline with fragmented data. We have the equipment, or yeah, in some context, I've called it like a bribeless compass that shows us exactly how to turn the tide. So, in areas where we have applied this data driven approach, we see that stabilization is entirely possible. And we have the proof that when you finally see the problem clearly enough, you can solve it. So now it's more about the political will.